Okay, continuing with section 6.2, we were finishing up problem number 10 and I had begun to draw it. And this is where I had gotten to thus far. I was telling you that this leg that runs up and down is the short leg, which is 1/2 across from the 60 is always your long leg, which is square root of 3/2. You don't have to keep labeling it short leg and long leg. I know you're going to eventually memorize that always across from 30 is a short leg. And with respect to a hypotenuse of 1, which you have in almost every problem, this is 1/2 of that. And then this multiplied by square root of 3 is the long leg. But look at the quadrant you're in. When you're over here, x's are negative. And this leg, this horizontal leg, represents the x value. So don't forget to put that negative, or several of your answers are going to come out wrong. This, the 1/2, is a y coordinate. Y coordinates are positive in the quadrant that you're in, so that's positive. Okay, in this particular problem, for number 10, we were asked to find all of the trig values, starting with sine, then cosine, then tangent. So sine, whatever you put right here next to the trig word just means where you rotated to, how far you rotated before you stopped and built your triangle. Okay, so we rotated to 150. You can put 150 there. Now you pull out the definition for sine. Sine is defined as just the y value. Whenever you're in a unit circle, it's y/1. If this was anything bigger than 1, it'd be y/r. Okay, so my y value is that 1/2. Moving on to cosine at 5 pi over 6. Definition for cosine is x. X is the horizontal leg, so negative square root of 3/2. Okay, sine, cosine, then next we're going to do tangent at 5 pi over 6. That's defined as y over x. So your y is 1/2, your x is square root of 3/2 negative. And if you want to change this from a division problem, which it is right now, it's top divided by bottom, to a multiplication, you just float this to the top and multiply by the reciprocal of the denominator. That does not mean get rid of the negative. You might want to cross this off after you float it to the top so you don't mess with it again. These cancel, leaving you with 1 over square root of 3. The negative is still there. Don't forget to rationalize. Multiply the bottom and the top by square root of 3/3. That essentially floats the radical to the top where it is allowed to be. That's considered simplified while giving you regular 3 on the bottom. Don't forget your negative. Then if you want to get the reciprocal cousins that go with this, sine and cosecant are related in a reciprocal fashion. I don't know if I should be squeezing these in here, but this one's easy enough. It's just take this and flip it over. They are related in a reciprocal manner. So that's the answer for that. That's the answer for that. Related to cosine is secant. These two pairs that I just did that students tend to forget. One starts with an S, one starts with a C. Same thing with this pair. One C, one S. So take that, flip it over, and you have your secant value. It's just that it won't be simplified because you got to float that radical to the top. In other words, rationalize it. So that would be 2 square roots of 3 over regular 3 with a negative. Okay, last one that we got was tangent. Cotangent goes with this. We always mention the angle that we're rotating to. Now, let's see. This is what we got when we simplified it, rationalized it. I think let's back it up a little bit. This is what it looked like before you rationalized it. 1 over square root of 3. You're better off flipping that over. That way you don't have to rationalize again. So just square root of 3 over 1 with the negative still there. Flipping does not get rid of the negative. Okay, so that's all 6 answers for number 10. Okay, moving to number 11. Okay, number 11 is 17 pi over 4. You're going to notice that, hopefully you're going to notice that any amount of pi divided by 3, you're going to get what's a 60-degree reference angle. Let me explain what reference angle is, although they don't formally say what it is until the next section. It's the angle that ends up being connected to the origin. That's called your reference angle. Okay, you're going to need to know how far, what quadrant you're in, or else you're not going to be paying attention to the positives and the negatives. So you do need to know what quadrant you're in, but if you anything divided by 3 is I just pointed to this, sorry. Anything divided by 3 is a 60-degree reference angle. So instead of 30, you would have a 60 right here. And anytime you're dealing with a 60-degree reference angle, I mean, you could put a picture and just summarize here right now if you want. Anytime you have a 60-degree reference angle, your y value is going to be the long leg. You can just list it as a point right now. Square root of 3 over 2, that'll be your y coordinate. Your x coordinate will be across from the 30. So this will be 1/2. And of course, your r is always 1. Okay, that's when they talk about any amount of pi divided by 3. Denominator of 3 is your clue that you have a 60-degree reference angle right at the center. Whether your triangle's in quad 1, 2, 3, or 4 doesn't matter. That'll change negatives, of course. But you'll always have this as the x coordinate and this as the y coordinate. When they talk about any amount of pi, like right now the amount is 17 pi over 4. Any amount of pi divided by 6, then you're talking a 30-degree reference angle. That would be this picture up here. Again, the triangle can be in quadrant 1, 2, 3, or 4. But for no matter what quadrant it's in, if it's something divided by 6, look, this was 5 pi divided by 6. So we ended up with a reference angle of 30. Any amount of pi divided by 6, you're going to have that sort of picture. Might be in quadrant 2 or 3, but you are going to have a 30-degree reference angle. So instead of 1/2 in the front and square root of 3 in the back, it would be the opposite. Now you'll have 1/2 for your y coordinate, because I always figure out what the side is across from the central angle first, which is the y value. I always figure that out first, and then I look at the x value. But it doesn't matter what order you're doing it in. Across from 60 would be square root of 3 over 2. So you see that these are just the same two numbers as this, but switched around because of who's at the center. Here it's 60 degrees at the center. Here it's 30 degrees at the center. If they give you a problem with any amount of pi divided by 4, then you're talking a 45-degree angle. And you could draw that if you want, but if you have 45 degrees here and also up here, both of these legs are going to be square root of 2 over 2. That's the easiest one to memorize because the legs are not different. They're both the same. Of course, you do have to know what they are. Again, any of these pictures, you could have a 60, 30, or 45, but still be in another quadrant. It just so happens we are going to have a 45-degree reference angle, like I stated here, things having to do with a divisor of 4. You'll have 45-degree reference angle, but we're not going to be in quadrant 1. So you're going to have to know how to count in fractions. So let's do what we can here. Okay, so we're going to go, you might want to do this. This might help you to do this. There's different ways you could look at this. 4 goes in here 4 times. 4 completely goes in here 4 times. So it would be 4. 4 times 4 is 16. And from 16 to 17 is 1/4 left over. Okay, if you put that in your calculator, not the pi, if you go 17 divided by 4, you get 4.25. 0.25 is 1/4. Let's think in fractions. You're going to be forced in many problems to think in fractions. So we're going to go to 4 pi and then an extra 1/4 of a pi. Okay, so let's see. So this would be 1 pi, 2 pi, 3 pi, 4 pi. Even multiples of pi, you land right here again. And you can draw a circle if you want, if that makes you comfortable. And then we're going to go another quarter pi. This is half a pi. This is a whole pi. So quarter pi would be right here. But like I said, anything to do with quarter pi, you are going to have a 45-degree reference angle. But at least I know that in rotating 17/4, I'm really going 4 pi plus an extra fourth. Now that has nothing to do with geometry. That just has to do with you being able to convert this into a fractional form. This is before you ever took any algebra. Come straight down. You don't have to draw this if you just have it memorized that both the x's and the y's are square root of 2 over 2. My radius is 1. And then you answer whatever they asked you here. But they're asking pretty much the same thing for most of these problems. Sine, cosine, tangent, cotangent, secant, cosecant. So cosine, I think they asked for sine first, but it doesn't really matter. You can put them in order yourself. So cosine at 17 pi over 4, which gives you this picture right here. Nothing more than the x value, and the x value is the horizontal leg. Then might as well go and do the reciprocal cousin, even though they don't ask for them in this order. That's just going to be your cosine answer flipped over. So that will be 2 over square root of 2. If you were to rationalize this by multiplying top and bottom by square root of 2, you would get 2 square roots of 2 over regular 2. So that secant ends up just being square root of 2. Okay, got 2 of the answers. And then if I do sine, okay, well, I think you see what's happening here. You're just going to get the y value, which is the same thing. And if this is the same thing, you needn't bother doing the work for cosecant, because it's going to be the same work that I did for secant. And we already know that that's square root of 2. Moving on to the 5th and 6th trig values, you have tan. Look at your picture. Your definition is y over x. The y value and the x value are both the same, therefore tan is 1. When you go to do cotan at 17 pi over 4, it's just your tan value flipped over. So 1 flipped over, 1. There you go. That's your 5th and your 6th answer. All 6 answers. So you see that this is getting pretty much the same kind of problems over and over again. But you need to practice when you're first learning, so I'm doing a lot of them. Okay, let's see. How many more can I do before I go insane? Let's see. I will. Okay, let's do number 12. Okay, problem number 12. They start you off and they only tell you this. Okay, if they give it to you in degrees, better for you. Again, everything's going to result in a 30, 60, 90, or 45, 45, 90. This will be easier for you to count because it's in degrees rather than in pi form. Like in that last one, if you don't, if you're getting messed up with the 17 over 4, you can convert it into degrees. You just go 17 times pi, 17 times 180 over 4. And you'll have to still wrap around the circle the same amount of times. You'll still land in quadrant 1, but you won't be in pi form. So then you won't be dealing with the fractional thing. But a lot of problems you're going to be forced to deal with the fractional stuff. Anyway, if you went to 360 and then you asked yourself, how much more do I need to get to that? 360 plus 45 is going to get you to 405. So you are still at 45 degrees, just like I was in the last problem. Okay, with this being, I'm not going to do all these answers all over again.